The first law of thermodynamics, also known as the law of energy conservation, states that energy can neither be created nor destroyed. It can only be transformed from one form to another. For example, when you cook on a gas stove, the chemical energy in the gas is converted into heat energy, which cooks your food. Similarly, when you use a battery, the chemical energy stored in it is transformed into electrical energy to power devices like a torch or phone. The second law of thermodynamics states that heat always flows from a higher temperature to a lower temperature, and the randomness or entropy of a system tends to increase over time. A common example is melting ice. When you put ice in a glass of water, heat flows from the water, which is at a higher temperature, to the ice, which is at a lower temperature, causing the ice to melt. Another example is engine efficiency. No engine can be 100% efficient because some energy is always lost as waste heat. The third law of thermodynamics states that as a system approaches absolute zero temperature, which is minus 273.15 degrees Celsius, its entropy approaches zero. At absolute zero, all molecular motion stops. In cryogenics, substances are preserved at extremely low temperatures, such as storing organs for transplants. Another example is superconductors. Some materials show zero electrical resistance at very low temperatures, making them useful for highly efficient electrical circuits. The zeroth law of thermodynamics states that if two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. A practical example is how a thermometer works. A thermometer comes to the same temperature as the object it's measuring, reaching thermal equilibrium, which allows it to show the correct temperature.